Good morning, Gabriela. This is an excellent question. Thank you for bringing it up. I will try to explain it in this recording, and I am sorry that I'm responding your question late. I had back-to-back meetings yesterday, and I was exhausted when I come home, 9 p.m. All right, let's go ahead and get started. So we have three functions, f of x, g of x, and h of x. And we would like to obtain another function, if you will, which is going to be composed of subtraction of two functions, which is g of x and h of x. So because my new function g minus h of x is being constructed from these two functions, first of all, I need to look at their domains also. So I need to consider their domains. And I also need to consider the domain of those. And I need to look at, in the end, is there any violation between these two? What is the intersection between these two? So this is how we tackle this problem. So when you look at the domain of g of x, that is x squared minus 49. It is all real numbers. Don't need to capitalize everything. All real numbers. That's one way of you can say it. Or something like that. Or you can say it negative infinity to positive infinity because it's a polynomial, right? It's a quadratic function. The shape will look like x squared minus 49, something like that. You are gonna go 49 steps down, and these are going to be the intersection points, which you don't need, but it's good to know. So this function has no restriction as it's a polynomial one. There is no even root, so just let's remind ourselves the restriction starts if we do have an even root. Restrictions happens if we do have an even root, like square root or fourth root, or if we do have, for the even root, if it is a second root function, we call them rational functions, or if it does have a fraction like that. Okay. So we don't have any of those in g of x. It's negative infinity to positive infinity. Okay, let's look at h of x this time. So we are still in this phase. Let's call it phase 1. Phase 1 was we need to look at each and every function domains if they have restriction, and we need to write it down. Then we're going to look at the resultant function domain, which is phase 2. Okay, so h of x is 1 over x minus 3. Okay, we do have a denominator, which is this one. Then we can say that x cannot be equal to 3. Then we can write it as negative infinity to 3 union 3 to infinity. Okay, so we need to take this into consideration. Well, as a matter of fact, this one is not a consideration, right? We can just, because it's taking all real values, we can just omit that. So as I'm looking at your solution, you're writing g minus h of x. Nicely, you're finding that, right? That response of yours is correct, which is x squared minus 49, right, minus 1 over x minus 3. Well, the resultant function has a domain restriction also, right? And the domain restriction of that resultant function is coming from here, and that will be negative infinity to 3 union 3 to infinity, as it cannot be equal to 3, right? So that's why we are ending up as an answer This is the answer of that. And this answer does not violate h of x domain, so we can accept it. In Module 2, we're going to look at it more deeply. But for now, what we need to understand at this point, we need to look at each and every function domain, which is phase 1, and we need to look at the domain of the resultant function, phase 2. Okay. See if there is any discrepancies. We can't say that the resultant function has a domain of negative infinity to positive infinity just because we have this. No, we have a denominator, right? So we have a fraction. It's a rational function, so we need to take that into consideration. So that's the response for quiz question 4, question 6. Now let's look at question 7. All right. So for question 7, you are asking, how does the multiplication end up with like that? Okay, so we have 3 functions again, f of x, g of x, h of x, all right? So we're going to talk about the multiplication of that, and f of x is 8x minus 4 times 1 over x minus 6. Okay, f of x does have an invisible denominator. So let's say that we're multiplying fractions. How do we multiply them? Multiply across. So 12 over 20. Agree? That's the result of a multiplication, multiply across. So we need to multiply across here also. So then we're going to end up 8x minus 4 all over x minus 6, because we're going to multiply 8x minus 4 in square root with 1, then 1 with x minus 6. So this will be our resultant function. However, when we're looking at the domain, we have 2 restrictions there. We do have an even root that we need to consider, and we do have a denominator, right, that we need to consider also. So for even root 1, the top one, what do we want? We want that should be greater than equal to 0. This is restriction 1. Okay. And for restriction 2, we want x minus 6 not equal to 0. So we solve this one, add 4, both sides, 8x is greater than 4, x will be greater than equal to 4 over 8. When we divide each side by 8, I just skip a step here. So then x will be greater than equal to 1 over 2. All right, so then when we're solving this portion, x, think about it as if it's equal to 0, add 6 both sides, then x will be equal to 6, but we want it not equal to 6. So let's write it, these two, as an interval form. Okay. So what does that mean? We have a number line, we have 0, we have 1/2. We want to include 1/2 and over. So here, if it's a number line, we have 0, we have 6. We want to include everything but not 6. All right? Okay, let me just redraw it. Okay, so 0, 6. We want to include, all right, just wanted to use a different color there, yeah, so it could be seen easily. Okay, so we want to include everything but not 6. Okay, so we're going to put it in an interval form, so it was this. So how am I going to write this restriction, this column? All right, so I'm gonna do 1 over 2 included, and I can go till infinity. Here, what do I have? I'm coming from negative infinity to 6. 6 is not included, union 6 to positive infinity. Okay, so we need to get that into some kind of combination. So it would not be right if you go ahead and you put u between them. Okay, it wouldn't be right. Okay, this is not what we want, because we cannot take all this portion. We cannot have this, because it violates the situation here. Because for this one, the restriction 1, let's call it, restriction 2. For restriction 1, we want the numbers to start with 1/2, and from there we want it to go to infinity. So if you think it like that, together on a number line, we have 0, 1/2, and 6. So for 6, we want all the numbers here and all the numbers there. However, the red one is a restriction 2. However, for restriction 1, we want all the numbers there. So we want to get their intersection, and and we can't still include 6. We need to include 1, 2, 1/2. So then we need to write 1/2 till 6. 6 is not included. Then we go from 6 to infinity, and that will be our answer. Hope it helps. It's not an easy question, and again, thank you for bringing that up, and have a great weekend. Let me know if you need more explanation, or if you have any concerns, and if you're not convinced. See ya. Bye.